So this video is going to teach you how to interpret the mean absolute deviation once you find it. Our learning target today is going to be, I can interpret the mean absolute deviation, or MAD, of a data set. So yesterday we talked about finding the MAD. So just a little warm-up here, what we're going to do. You have to find the mean. The very first thing to do is to find the mean of the whole data set. So you have a 2, a 6, an 8, 12, and 12. If you add those all up, you add these all together, add, and you get 40. You added 1, 2, 3, 4, 5 numbers. Divide that by 5. Your mean is 8 of the whole data set. So that's what you put in this column here. These are all the same values, all 8. Now, do you remember? What do I do next? I subtract the mean from the data value. Alright, I don't have, the way that I set these subtraction problems up, I don't have any negative values, but I'm just going to go ahead and I'm going to copy the distance away from the mean each data point is. I'm going to add those all together. So 6 and 2 is 8, and 8 and 8 is 16. And I had 5 data points, so I divide that by 5. My MAD, my mean absolute deviation, is 3.2. Okay, there we go. Nice and low. So that means I can be confident in my data. So here's just a review of the steps that we use to find the mean absolute deviation. If you didn't get it the other day, you can get it now. Take a screenshot, stop the video. You can write it down, but make sure you have it in your math notes somewhere. So, again, just a little review. The mean absolute deviation means, in math statistics, that's a whole line of statistics, a whole line of math that you can go into. It's the average distance each data value is from the mean of the data. So today we're going to talk about analyzing that data and why it's important that you can use it. Alright, the lower the number, or the lower the MAD, the data is more consistent and there's less surprises or variability that's going to happen if you carry on something that you made the survey for, that you carried out the data for. If you have a higher MAD, that means the data could show lots of differences and it's all spread out. There's not a consistent amount of choices or things that are happening with that data. So you can't really be confident in the fact that any predictions you make will actually happen. Alright, so the meteorologist recorded the rainfall in centimeters at 10 different locations. during one day and arrange the amounts as shown. All right, 2, 2, 2, 2, 3, 3, 3, 4, 4, and 5 centimeters. Now it tells you right here the mean is 3 centimeters. So you go ahead and you put your data values here. 2, 2, 2, 2, 2, 3, 4, 3 threes, 1, 2, 3, 4 fours, no, 2 4s, and a 5. And it's already told you what the mean is. So all of these will be 3. And then you subtract them. Well, I'm going to do them so I don't have any negative numbers. 3 minus 2 is 1. Again, 3 minus 2 equals 1. 3 minus 2 equals 1. You have to do it for every data value you have. 1, 2, 3, 4, yeah. 3 minus 2 equals 1. 3 minus 3 equals 0. It's right on. 3 minus 3 equals 0. 3 minus 3 equals 0. 4 minus 3 equals 0. 4 minus 3 equals 0. And 5 minus 3 equals 2. So we have 0, 0, 0. 1, 2, 3. Oh, this is a 1. I am so sorry. And this is a 1 and a 2. When you add all of these up, you get 8. All right, and we had 10 values, so we're going to divide that by 10. Our mean absolute deviation is a 0.08 centimeters. Okay, so that's the expected value of the rain is going to be very predictable. 0.08 is pretty low mean absolute deviation. All right, let's talk about how we're going to put this into practice. A chef wants to hire someone to work in the kitchen. There are 2 candidates, Sally and Nader. He tests them by timing how long it takes them to make each of 4 meals. The data is in the table below. All right, so Sally made 4 meals. A, B, C, and D. She took 2 minutes to do A, 8 minutes to do B, 5 minutes to do C, and 9 minutes to do D. And now we have Vader. All right, Nader took the same 4 meals, and he took 5 minutes to do A, 6 minutes to do B, 5 minutes to do C, and 7 minutes to cook D. Okay. He decides to calculate the mean time it took each candidate to make the 4 meals. He will hire the person who took the less time. So we're going to find the mean. All right, we got to calculate the mean for both persons. All right, so we're just going to add up the times it took for them to prepare the meals. All right, so 8 and 2 is 10, and 9 is 19, and 5 is 24. Right, 24. All right, 5 plus 6 plus 5 plus 7. 5 plus 5 is 10. Right? 5 and 5 is 10, 16, 17, 18, 19, 20, 21, 22. 22. Right? 10, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay. Alright. So if we divide by 4, it took 6 minutes. Here, 12, oh wait, that's 12 and 11, 23, right? I'm going to get my calculator out and make sure on 5 plus 6 plus 5 plus 7, 23. Alright, and if we divide that by 4, divided by 4, 575. 5.75. Okay, we're going to round that up to the nearest minute, so that was 6 minutes. They both took 6 minutes. So they're equal. What are we going to do? Well, he can't use that to make a decision because they both took about 6 minutes to prepare those meals. So that data didn't help. He decides to calculate the time between the mean and the actual time it took to create the meals, the mad absolute deviation. Let's calculate Sally's mad. Alright, her mean was 6. We're going to go ahead and put those 6's in here. And we're going to put her data in here. This is how long it took her to make these meals. 2, 8, 5, and 9. Now we're going to subtract. 6 minus 2 is 4. 8 minus 6 is 2. 6 minus 5 is 1. And 9 minus 6 is 3. Now let's add these all up together. 7, 8, 9, 10. So this is 10. And she had 4 meals, so we're going to divide this by 4. Her mean absolute deviation was 2.5. Okay, 2.5 minutes. So when Sally cooks one of the meals, we're going to say it's going to be expected to take about 2.5 minutes more or less than 6 minutes. So it could take her 3.5 minutes, or it could take her 8.5 minutes. Alright, but somewhere between the mean and plus or minus 2.5 minutes. Okay? So remember that. Let's talk about Nader. Okay, Nader's mean also was 6. So we're going to put the 6's here. And his times were 5, 6, 5, and 7. And we're going to find the difference between these. This is 1. 6 minus 6 is 0. 6 minus 5. It looks like he's more consistent. Minus 6 is 2. So his absolute value, 2, is 4. And we're going to divide that by 4. So that is, his MAD is 1 minute. His mean absolute deviation. So what does that mean? That means so when Nader cooks one of his meals, he's expected to only take 1 minute more or 1 minute less than his average of 6 minutes. So it might take him anywhere from 6 plus 1, or 7 minutes, or 6 minus 1, 5 minutes. It'll take him anywhere from 5 to 7 minutes to cook a meal. Okay, because his deviation is 1 minute. It's smaller than Sally's. Look here, Sally, her mean absolute deviation is 2.5. So she's going to take anywhere from 6 minus 2.5. That's going to be 3.5. Anywhere from 3.5 minutes to 6, 7, 8.5 minutes. We add, plus or minus that 2.5 minutes. It's going to take her longer than Nader. It's going to take him anywhere between 5 and 7 minutes. It's going to take Sally anywhere from 3.5 to 8.5. That's a big margin. Let me check my 6 minus 2.5. Yeah, 3.5. So, now we can make a better decision. The chef is going to make a decision. Who would you hire? Would you hire Nader, who is more consistent? He between 5 and 7 minutes. Or would you hire Sally, would be anywhere between 3.5 to 8.5 minutes? Well, the chef sees that Nader's times is lower than the mad of Sally's times. This shows that Nader is more consistent in his cooking times. So based on this, the chef decides that Nader is the better candidate because his work is more consistent. Alright, so Nader gets the job because he's got a lower mean absolute deviation than Sally. That is a practical application for this information. Alright, here's one more. A farmer is testing 2 different types of plant food in his garden. He used ultra feed on 5 of his plants and mega feed on 5 other plants. He measured the growth increase of each of the plants and recorded the results in the table below. So when he used ultra feed, the one plant increased 1.2 centimeters, 1.4 centimeters, 0.9, 0.8, 1.7. All right. This was plant A, plant B, plant C, D, and E. But when he used mega food, look, plant A increased 1.5, B increased 0.6, C 1.1, D 1.3, and E 1.0. So when you find the mean of both of these sets of data, the ultra feed mean, the mean, is 1.4 centimeters, and the mega feed is 1.1 centimeters. Can you predict which food will produce less variability? Which plant food would you pick? The means are pretty close, 1.4 and 1.1. I don't know. Maybe there's another measure we could do. Yes, we can find the mean absolute deviation, or MAD, and see which one is more consistent. So when we calculated the MAD for each of the different types of plants foods, his results were this. The ultra feed had a 0.28 centimeter mean absolute deviation, and the mega food had a 0.24 centimeter MAD. So which plant food would you buy? Well, when we compare these two, we see that the mega feed, right down here, produces less variability. It's a smaller MAD. Okay, it produces less variability than the mega feed, or the ultra feed. So the farmer wants his plants to grow as predicted. He doesn't want, he's putting a lot of money into this feed and these plants, and he wants to make sure his plants are consistently growing the way they're supposed to grow. So he chooses the mega feed to put on his plants for harvest. This is a real, this is a real live question. This is how a farmer would figure out how they could get the most consistent growth out of their plants so he can plan for his harvest. All right, so you have to think about what the scenario is. All right, this is for, what food should the farmer buy? The last one was, who should the chef hire and why? And they all figured it out because they used the mean absolute deviation as another measure of center. So you're going to practice these skills. Again, you have an IXL assignment, mean absolute deviation. The quick find number is A5C. And I want you to spend your total 30 minutes on this. This will be the day, this is how much time you need to spend every day on working in IXL. Alright people, I know you can do this. Use your brain and just work out some problems. So go ahead and take a break. You can go ahead and log out, and I will talk to you another day. Bye.